Hi everyone, and welcome to the virtual version of Arles Industrial Tag. This is the third meeting of our series. Usually it's held in person, but actually we're pleased to hold it virtually because it allows for a much wider audience. So it's great to have everyone here. The agenda for today will be as follows. We've lined up 4 presentations from some great technologies and a variety of subject areas. Each presentation will be 10 minutes long, and that will be followed by 10 minutes of Q&A. There'll be a short break in the middle, so it'll be after the first 2 technologies, and it'll be about 5 minutes, depending what time we have. Just give a chance for everyone to stretch their legs. Then we'll be back at approximately 3 p.m. AEST time, that is. I just want to do a bit of housekeeping before we kick off. So all attendees that are joining us on the GoToWebinar, you will actually be muted for the whole of this. We also wanted, because we're using GoToWebinar and YouTube Live, so hello to all our YouTube Live listeners, we're going to put all the feedback and all the Q&A sessions that will all be available on Mentimeter. So if you go to menti.com, and use the code on the screen, so 804198, you'll be able to get to our comments and Q&A section. So thanks to everyone who's on there now. Appreciate it. You'll be able to comment on any of the strengths and weaknesses, opportunities and threats of each of the technologies, as well as submit questions to each of the presenter. You can submit these at any time or make any comments at any time during the presentations. And just use the back and forward buttons through the system. So if you've forgotten anything and you want to go back and put additional comments on there, you're welcome to. This presentation is also being recorded and will be available to everyone who registered on GoToWebinar. It'll also be available on Arles Global's YouTube channels, so you can view it anytime. Following this presentation, I'll also be circulating a feedback form. So just a bit of a survey. We'd really appreciate it if you fill it in. It really helps us in understanding whether or not which technologies you'd be interested in, which technologies you'd like to follow up with, and how the YouTube and live streaming went and how you felt about using Mentimeter. So it just gives us a bit of feedback on that. So just to start off, I just want to welcome you all here. Like I said, this is the third industrial tag meeting in our series. The aim of the industrial tag basically is to bring together some market-leading industrial players and also some emerging step-change technologies, with ultimately the goal to solve some critical environmental challenges. We've had the first 2 meetings in Melbourne, so you can see a couple of pictures here. They started about a year ago. Those with various manufacturing and mining companies local to Australia, but we're pleased to have nearly everyone back with us today, and lots of new people, so I welcome everyone from the Asia Pacific region. This is just a few of the companies that have managed to come along to our meetings. I hope to add a lot more to this list, so I appreciate again everyone attending. I thank everyone for their ongoing interest in the work that we're doing. So what to expect today? Well, we hope to introduce you to 4 exciting new technologies. You'll be able to ask questions and provide feedback on those. We'll be sharing the presenters, that feedback with your peers as well as those presenters. Hopefully you'll find it all very educational and enjoyable. So just before we kick off, I just want to give you a bit of background on Arles. A few of you may not know who we are and why we're doing this. Arles' vision is to bring basically together leading environmental technologies and industrial end users to facilitate the adoption of these technologies, as well as exposing those end users to innovative solutions to their sustainable challenges. We basically like to have a positive impact on the world and improve the environment for everyone. We're a global company, as you can see, and we like to achieve a lot of our aims through our Global Innovation Network. Arles has been running a well-patronized technology assessment group, or the TAG group as we call it, globally. We have about 150 end users, water utilities mainly, since 2011. And we now run various industrial versions of this tag through Europe, South Africa, and in the Asian Pacific region. We've become our various innovation programs. Through this, we've assessed over 8,000 technologies, and we have a dedicated team who work through the technologies and provide the due diligence. So where are we taking this? So we're the industrial tag in the Asia Pacific region allows companies to benefit from cross-sectional collaboration and solve problems quicker and more effectively. And we're going to continue to provide this service, hopefully to save time and money. But in some cases, we have worked with companies and gone on to work with companies as part of an ongoing innovation partnership. So as well as the ITAG, we'll be working with these on our innovation partnership model. So just to give you a bit more detail about how that works, it's an opportunity basically to work through a process where you initially identify your challenges and needs. Perhaps you're benchmarking your innovation process against other industries, and then I will go and look for opportunities and technologies that match those challenges and your specific requirements. The next step then is to look at getting those technology companies to pitch to yourselves. So we hold collaborative forums, we discuss the technologies, develop a business case, just all in the aim to move that technology forward through into that evaluation, planning, and implementation stage. Finally, the final step in that sort of process is the collaborative trials or collaborative trials, depending on whether or not this process is done with just a single company or a group of companies. It also allows opportunities for sharing funding, resources, and I'll act as an independent facilitator through the whole of this process. It doesn't have to be exactly this model. This is an outline for the model that we've used, and we've obviously adapted it depending on the companies that we're working with. And like I said, it can be with individuals or with a consortium. But we'll continue to do the industrial tag meetings. We'll continue to bring everyone together. We've recently taken the innovation partnership model and the tag model, and we've melded them together in a new innovation program. We re-tendered for our contract with the Water Services Association Australia, and we were successful. And now we've just recently launched the WLab. So TAG has evolved into the WLab in Australia. We're pleased that 25 Australian utilities have signed up again to the WLab and have become members. This is all based again on that innovation partnership program, and we'll go on. The first meeting is in a few weeks' time, so it's a very exciting time for us. So, moving on, we'll go on to start the technology presentations, because I'm sure you're all keen to hear from our presenters. The first presenter is Aquafortis. Before we go on to Aquafortis, though, I just want to quickly remind everyone the Q&A will be on Mentimeter. So go to menti.com and put in the code 804198. Like I said, you'll be able to move back and forth through that. There's 2 pages on strengths and opportunities for Aquafortis and one on the weaknesses and threats for Aquafortis. So please just put your comments in there, what you think as the presentation goes on. And then following that, you'll find the Q&A for Aquafortis. So anytime, just put your questions in and we'll answer them following the presentation. Great. Okay, so we'll move on to the first presentation, as I said. Jessica Lamb from Aquafortis will be presenting their solvent extraction process. It's potentially used for recovery of water from brine in RO applications, but I think there are lots of different opportunities for this technologies. So I'll hand over to Jessica and let her talk about it more.
Hello everyone, just give me a second. I'm just going to share the screen.
Great.
Oh, I think I'm showing you currently.
No, we can see your presentation.
Oh, you can? Okay.
That's great.
All right. Okay, hello, my name is Jessica. I'm the CEO of Aquafortis. With me, I also have Daryl Briggs, the founder and CEO of Aquafortis. He will be doing the answer question and answer session. Okay, so Aquafortis, we are a brine management technology. We deal with how do we deal with the higher salinity salts? Now, compared to current high salinity salt technologies, we are 60% less in operating costs, and that is because we're a non-thermal ZLD technology. So ZLD stands for zero liquid discharge. Because we're a zero liquid discharge technology, we are able to crystallize out all the salts. We recover 98% of the water, and from the water recovery, we're able to increase freshwater availability to the local environment. Now, we deal with as I said, the high salinity salts, and this is where the cost of disposal averages from $20 to $900 per tonne in just disposal costs alone. Mainly the ZLD space is caused by regulations, which are forcing industries to take on technologies that will allow them to have no liquid discharge coming out of their plants. Now, this is affecting oil and gas producers, industrial producers, power plant operations. Now, we can also treat mining tailings, but that is separate from the ZLD situation. So how we're able to deal with high salinity wastewater is that we have sorry, let me just quickly go back. The normal treatment train is that it starts with the reverse osmosis, which deals with brine that starts at about, like seawater, which starts at a total dissolved solids of 35,000 parts per million. Reverse osmosis usually can concentrate up to about 60 or 70,000 parts per million. At that point, RO tops out and cannot take the concentration any further. And then they bring in a thermal evaporator, which concentrates it up to about 72%. And then to take out the last concentration, you take in a thermal crystallizer. If you look at it, a thermal evaporator is like a closed pot. It boils water, and therefore it's very high in energy use. A crystallizer is like an open pot, so it uses intensively more water energy, which is why they usually is a PED system. And that is the only way to get to ZLD. What we do is that we replace both the thermal crystallizer and the thermal evaporator in just one step. So in one step, we're a true ZLD technology. Because we replace both the very energy intensive technologies, we can reduce energy by 90% and in turn saving 60% in operating costs. We also can recover all the water out of the process. Now, the reason why we can do this, our technology works like this. We use two chemicals. These are both liquids, the absorbent and the regenerant. We pump brine into our system. The absorbent only absorbs water. So when all the water is absorbed from the brine, the salts orphan out and naturally crystallize out. The water is then passed to the regenerant cycle. The regenerant is used to dry the absorbent, so the absorbent is able to reconcentrate back up so they can absorb more water. Now, the water moving into the regenerant means that we need to take the water out of the regenerant so that it can be reconcentrated back up for use again. We pass it across the membrane, you get clean water on one side and dry regenerant on the other side. And that is how we are non-thermal technology. We have 6 patents filed, and this is over our absorbent, regenerant, and the process. Now, compared to current ZLD technologies, so these are the generic technologies currently out there. The only other technology that can take it to ZLD is a crystallizer. But as you can see, they use significantly more energy than we do. We actually use similar energy to a high efficiency RO. Now, this is again a comparison compared to other ZLD technologies. As you can see, CapEx wise, we are cheaper than the thermal crystallizer, which is the only other technology they can take to ZLD. Compared to a low temperature evaporator, we're similar in pricing, but we really shine on the operating costs. As you can see, we are only $3 per cube compared to all the other technologies. Now, as I said, an evaporator needs to be paired with a crystallizer to get to ZLD. We currently have 2 established customers. We have one in US oil and gas that deals with produced water, And we also have another client that's in that deals in industrial wastewater applications in Europe. We have a pilot plant currently that does 100 barrels per day, which is about 16 cubic meters per day. We have also tested a number of different commercial brines, as we tested textile brines, oil and gas, seawater, RO reject, winery, fly ash, and as you can see, the highest TDS we've treated is actually 454,000 parts per million. It's a very concentrated brine, and we've been able to treat that. Now, our process is very simple. The parts that go into it, as you can see, it's just like a mixers, pipes, pumps, and tanks. So we'd use off-the-shelf componentry. So it's a very simple and cheap process. Now, if you're interested in engaging with us, this is our engagement process. Through our process, you can actually test our technology, evaluate it by sending us a sample of your brine. We test it with our technology, and then we provide you a report as to how well it went. And if you're interested after that, we can move forward from there. So thank you for listening to us. And I will now pass you to Daryl for the question answer session. Thank you.
Thanks, Jessica. Is there any questions?
Thanks, Daryl. Thanks, Jessica. I appreciate taking the time to do the presentation for us. It was very interesting. I just wanted to go back and remind everyone to use the menti.com and use the code AT4198. Go to the Aquafortis Q&A page and just put your questions in there. You can ask as many questions as you like. We haven't got anything at the moment, but we're just waiting to see if anything will come up. I have one question in the meantime. So just around the work that you've done so far, have you done anything in the Asia Pacific region, or is it mostly done in the oil and gas region in the US?
Yes, so we've tested a number of brines from Asia Pacific and textiles, winery waste, electronics, and potash production. So yes, we have done some evaluations. As far as commercial applications, that's currently limited to the United States and moving into Europe.
So we've also tested dairy waste in New Zealand. However, we're currently not focusing on dairy, but we have tested it too.
Okay, great. Okay. So I have a couple of questions on a few questions down on the Mentimeter. I have one actually on GoToWebinar. We're not using the GoToWebinar questions, thanks Ian, but it's fine, I can still see it. So just a question here around how does your system handle organics?
So that's it depends on the organics is a short answer. And it also depends on the proportion of organics to the salts. So typically we recommend to keep the organics lower than 10% of the salt loading. And the reason for that is simply because the solids handling system, so the devices that take the crystallized salts out of the absorbent, they tend to not like things that are sticky. So they like free-flowing salts. If you do have quite a sticky mass, we can still treat it. It just needs a different method of solids handling. So you'd be looking at using something like a decanting centrifuge rather than a hydrocyclone.
Right.
As far as the chemistry of the process is concerned, it doesn't really care about the organics. It will strip water out of it. So we've done dairy wastewater, as Jessica mentioned. We've done brewery wastewater. It's very efficient at taking the water out and solidifying it, but you do tend to end up with a bit of a sticky mass as far as your solids are concerned. Okay, and
how do you handle the solids when they're sticky mass like that? Is it just disposal to landfill?
So it's more the separation of those sticky solids from the absorbent and the technique you use. So the technique we would recommend is a decanting centrifuge, which basically scrapes the walls, and then that will result in a cake, basically. And generally, the energy value of those solids is high enough that you can put them through to anaerobic digestion and get the fuel value out of them that way, or you can incinerate it. If you send it to landfill, you'll end up getting anaerobic digestion anyhow in the landfill itself.
Right. Okay, that's great. So we have a few questions now on Mentimeter, so thanks everyone for using that. So I'm just going to have a quick switch over the screens just so you guys can see the screen as well. Okay, so the first question here is just around how often do the solvents need to be replenished?
Okay, so the solvents don't need to be replenished per se. They're quite robust and they don't age, but you do get attrition. So you do lose some of your solvent with the waste that go out at about a rate of 100 ppm. Also in our designs, we keep a very small amount of these solvents online. So the entire retention time of the system, we try to keep below 10 minutes, typically around 3. And that means over a period of 3 or 4 months, if you have a high flow rate through it, you will end up replacing all your solvents by attrition. So yeah, it is a consistent top up to just manage your losses from the system.
Right. Okay, thanks for that. Let's move on to the next one. Any successful applications in the dairy industry? If so, and what type of effluent, wastewater? So I know you made some comments about the dairy industry applications. If you just expand on that.
Yeah, so we've done DAF waste. We've done what were the other ones that we did?
Cream cheese whey was the.
Yeah, we did digester centrates. It was basically all from cheese processors. So the chemistry worked wonderfully and reducing it to solid mass, but this is where we talk about it being sticky. You would need to use a decanting centrifuge for the solid separation. Because of this, we haven't pursued this application because it is a process change and we haven't had a client motivated enough to go through that process. So typically we stick with free-flowing salts, which typically have organics loadings below 10%. So yes, it does work, but we haven't pursued the application.
Okay, maybe opportunity more for the dairy processors on the line to to talk to you guys a bit further about it.
Okay.
Okay, move on to the next one. Okay, so how well does the system handle organics contaminants in the grocery? So I guess we've answered that one already. Yeah,
I might elaborate on that. It does depend on the organic. So if it's a bulky organic like a protein or a fat, they will get rejected with the salts in nearly all cases. Really the only exception to this is small polar organics. So things like ammonia, methanol, things like that, which as far as the system is concerned, doesn't look that much different to water from a physiochemical perspective. Those compounds transmit through the system. So they go into the absorbent, then they go into the regenerant, and then they go out the backside of the membrane and they end up in the water. So that's things such as ammonia and methanol. So it doesn't affect our process, but it'll either be rejected by our process or it'll transmit through our process to the effluent water. So if you have a high ammonia stream in the saline wastewater you're trying to treat, then just be aware that you will need to post-treat the ammonia in the effluent water.
Okay, that's great. Thanks, Daryl. Okay, so that's answered. Move on. Okay, so what substance material do you use for the absorbent and regenerant?
So those are our proprietary compounds that we don't talk about.
Okay.
But it is something that we make and that Aquafortis supplies to the process.
Is it readily available, or is the constituents that very readily available? There's there any issues with supply?
So it's made from so it's synthesized from commodity chemicals, but you still have to go through that synthesis process. So that's what we do. We get the commodity chemicals in, we synthesize it into the bulk chemical for the absorbent and the regenerant.
Great. Thanks for that. It's a good answer without answering it. Thank you. Okay. So we have a question here. I assume that the absorbent is lost with the salt over time. So I think you've answered that one already as well, but I don't know if you wanted to touch on it again. Yeah,
so that's at that 100 ppm loss rate. So, this is basically through clingage. The absorbent doesn't like the salt, but some of it gets carried across with the salt just because it adheres to the surface of it, or it gets trapped in the crystal structure. And at 100 ppm, all you're doing is you're putting the salts into a filter press post obtaining the slurry, and then you're basically blowing the excess absorbent out with compressed air. That leaves a residual about 100 ppm. Through the economics that we've looked at, it's never been that worthwhile to try and evaporate the salts out or evaporate the absorbent out to try and do any other form of enhanced recovery. So typically you just wear the loss of 100 ppm of the absorbent with the salt.
Okay, thanks for that. The next question is, are the solvent attrition losses costs incorporated in your operating costs in the table shown in the presentation?
Yes, they are. So it's all inclusive.
Okay, do you want me to hand back just so you can have a look, or just to talk about it? Or?
Nope.
Okay.
So basically, that cost is energy plus losses of absorbent and regenerant.
Right. That's great. Thank you. Right. Let's move on to the next one. Are there any additional solid or liquid waste streams that result from the treatment process that require further treatment or discharge to wastewater or landfill?
No. So your solid waste stream is the solids that we are dropping out through the process, and you will need to dispose of those as you normally would if you had them.
So it's just basically whatever salt is in your wastewater, so sodium chloride, that's the common salt we find, calcium chloride. So that salt is in your wastewater. When we remove all the water, it just becomes, a solid form, and then it's usually a really mixed salt, so you need to dispose of that. But sometimes we get a brine that does have only a very pure salt in it, so just calcium chloride, and then at that point you could actually maybe reuse that or resell that.
Yeah. And some of the contaminants we talked about, so if you had, say, ammonia going through the system, then that would end up in the permeate water and would need post-treatment, most likely. But in the absence of salt, it's generally quite easy to deal with.
Yeah. Okay, that's great. So next question is, what is the resultant water quality out of the membrane?
In all our testing, it's bloody good. So in the US oil and gas test we did recently, we got a output salinity of 500 ppm from a starting salinity of 250,000 ppm. So we had a massive turn down in output water quality. It is technically can be used for quite a number of things, but we've never pursued potable uses because that means we'd need to go through a number of FDA hoops. So we generally recommend that you use the water either back into the process or as a cooling tower or boiling feedstock. It's excellent for those uses. Or surface discharge, so discharge to agriculture or discharge to a water source. We just will not stand by you drinking it. That's all.
Okay. It's a good warning. Good warning up front. Okay. Can the salt, calcium chloride, be used for sodium chloride? Sorry, can be used for human consumption, including the solvent in it?
Yes, you can. But what you do is you just go through an incineration step. So you would, no, it's probably not quite the step of calcining it, but effectively you'd heat the salt to drive the solvent out.
Right.
Now, heating pure salts, they have a very low heat capacity, so it doesn't take much energy to get them very, very hot. So once you've removed all the water, it's not very energy intensive to just take it that last step and get rid of the solvent.
Yeah. Okay, that's clear. Thanks. Next question, how does it handle silica in bore water?
It rejects it. So the silica will end up in the salts. So in these produced water trials, silica, boron, a couple of other nasties are quite common to come across. You could essentially consider produced water as a type of bore water. And yeah, the silica ends up in the salts in all circumstances. So it goes to not detect levels out the other end.
Right, that's interesting. Thanks. Okay, we'll move to the next question. What is the lifespan of the absorbent and regenerant?
So as far as we can tell, pretty much indefinite. But, it might end up having a shelf life of something like 3 to 5 years. The way that we approach this, though, is that because we have so little online, through attrition, you end up refreshing it probably on a 3 to 6 monthly basis anyhow.
Yeah. Okay. Moving on to the last question, I think. Is the LDZ technology competitive advantage based on superior decoupling of the water molecules at the interstitial level on Van der Waals level?
That one I have no idea.
Okay.
I need to get a chemist up to talk about that, and it'll probably be an hour-long discussion. The major advantages is that you're not going through the phase change. You're not going from liquid water to, steam, not to gaseous water. So you don't have that penalty. It's just liquid to liquid the whole way through.
Okay. Well, maybe, so let me just pop this back onto my first screen. So maybe if you're the one that asked that question and you'd like to learn more, please contact Jessica at jessica@aquafortis.com. I'm sure her and Darryl will be able to put you in contact with somebody else in the team that maybe, or contact with those guys, have a longer discussion about maybe the physics behind the process. If anyone else has any other questions on Aquafortis, feel free to add them in at any time. We'll forward them through or put them on there's an opportunity in the feedback form to put some additional questions in there as well. Or like I said, contact Jessica at aquafortis.com, and I'm sure she'll be happy to follow up with you guys. Okay, well, thanks Jessica, thanks Darryl. I appreciate that presentation and going through all those questions.
Thank you, Karen.
Much appreciated. Thank you.
Thank you, everyone.
No worries. So, okay, we'll move on to our next presentation. So, Liam from Nanobubble Systems will be talking about their nanobubble generation, mainly I think for enhanced DAFs. So, I'll just hand over to Leon to tell you more about that.
Oh, all right.
Hi, Leon.
Thanks very much. Can you see and hear me?
I can hear you, and
Okay,
just
cool.
Yep, there's your presentation. It's great.
Cool, awesome. Okay, thanks very much for the introduction, Karen. Okay, so just a little bit about us first. I work out of Australia from Wollongong, Wollongong based, and Nanobubble. I work for a company called Nanobubble Systems, who's owned by Henley Group, which are a Kiwi-based company with 2 workshops in Auckland. And we are partnered with a US-based company called Molia as well, and we sell their Nanobubble product, Nanobubble machines here in Australia, New Zealand, and around the sort of Asia Pacific region as well. Molia are a new sort of tech startup from California. They've been around for 2.5 years now. And they've got over 400 installations over a variety of industries. But they're sort of a new technology that's come along in leaps and bounds. At present, we sell most of the machines in algae and odor issues in ponds and lakes, and also hydroponics is the two biggest sellers, but also aquaculture, sterilisation and cleaning, any sort of gas transfer that you want to get into water for extremely high efficiency of getting the gas into water, and DEFs, or dissolved air flotation, which is what we'll focus on today. And if you have any other questions about the other areas, you can just message me later. So I'll just start with a bit of an introduction to what are nanobubbles for people that aren't familiar. So nanobubbles is just any way of transferring a gas to water, but the size of the bubble is much, much, much smaller than the sort of previous sizes that we could get over other machines. So when we use a pressure vessel to put air and water in a DEF, the size of the bubble is the micro bubble size. Our nanobubbles that we put in are about, on average, 500 times smaller diameter than the average size micro bubble. And just to give you an example of how much bigger difference that makes, we could fit 64 million nanobubbles into one microbubble. So it's a really big drop in size. And it's because of this drop in size that we get the sort of unique characteristics of the nanobubble. There's a couple, but we'll just focus on the two ones relevant to DEFs today. So the key important ones for the DEFs are that with that drop in size, we get a much greater jump in the surface area or interfacial contact area between the gas and the water. So you get a lot more bubbles touching whatever's suspended in the water. And then the second part is that as the bubble size gets smaller and smaller and smaller, it gets a negative charge on it, and now we're super, super small. That charge is quite strong, and that helps get flocculation. And again, so just much greater contact between the gas and whatever's suspended in the water. And basically getting greater contact means we can remove more from a DEF, and it also means that we can get tighter contact of those bubbles onto whatever is suspended in the water as well, which in the next slide, or in the next couple of slides, we'll see pretty much means we can take out a lot less water with whatever's getting floated up in the DEF sludge. So here's just a little slide just showing really basically the principle of what's going on. So when we put the nanobubbles in water, they don't actually rise on their own. They're sort of neutrally buoyant and they spread out. But with the negative charge in it, and you get flocculation, it's sort of, once you get a lot of flocculation around something, you get a combined lifting power that we can see on the right-hand side. And that's how things rise up. Rather than putting bigger bubbles in that are naturally moving up, and taking stuff with them, ours sort of spread out, and then they get flocculation, and then they rise when they sort of form big groups of bubbles. So how does this help in the DEF? I guess what we're seeing from the sales in the DEF area from our guys in the States, their biggest reason people are buying them at the moment is that we get a much higher percentage of solids in our float sludge. And so obviously the benefit is that you can get a pretty big reduction in the total volume of sludge that you have to dispose of and handle. And so that's really big savings there. Pretty much every installation they've had in the States, they've never had a solids percentage of sludge less than 15%, whether they're starting at really low percentages, 3 or 5% or 10%. It's always that's sort of the key figure you get, and that's the primary reason most of the sales have happened. The next strongest reason is people have played around with the combinations of chemicals they're using. So what we've seen a lot as well is people potentially going away from expensive built flocks that they're using to get that high solids percentage and obviously reduce their disposal costs, and instead using much cheaper combinations and using the chemistry of the nanobubbles to get that high solids percentage again. So that's another sort of big saving. The third reason is just a straight increase in removal efficiency from your DEF. So it sort of varies a lot depending on lots of things, and they haven't really got a good handle on why some get really good response and some don't. But typically they say the average over all of the ones they've done is about a 15% improvement where you're replacing a pressure vessel with a nanobubble system. So to give an example of that, if you were removing 80% BOD, you'd be removing 83% with a nanobubble system where you're replacing pressure vessel aeration. And it can range anywhere from 0 to 35% improvement. So obviously, if you're town-based, it's a really big advantage, especially if you're having to send your water down to the local wastewater treatment plant and you're getting charged on what's in the water. Really big advantages there. And then as well as if you've got pond-based systems, you've just got less going into your pond, so you can increase your treatment capacity or less sludge build-up and that sort of thing as well. Lastly, you can typically we get a pretty strong reduction in power consumption when we go away from pressure vessel system, because we're not needing to use large pumps to push water through a pressure vessel. Our systems are really low pressure system, I guess. So I've just got a quick picture of a conventional rectangular DAF with a recycle pump in your pressure vessel. How we do it with our system, we can replace the whole system, leaving it there, but just build our own system set up in parallel, taking water exactly the same way, but just passing it through the nanobubble system and then back into your DAF. We have a clean wash system as well that we can potentially install in certain cases where the DAFs aren't running 24/7, because when our machine's running, and I'll explain a bit further down in the next slide, it's a diffuser-based system. So if it's left with really strong wastewater sitting for a long period of time, you will get biofouling. And in cases where it's not running 24/7, we recommend a clean water wash after you turn your DAF off at night, so we can build our systems with separate little side stream that will run for an hour when you turn your DAF off at night. That's what it becomes. So just to give an example of how our nanobubble systems work, if you can see me on the screen there, my pen in my hand. So basically we have like a ceramic tube that's hollow with a metallic coating. We push really high pressure air into the tube, and this is hollow, just like my pen would be on the inside. And under high pressure gas, you're getting tiny little tubes, nano-sized tubes, pushing out into the water. And then we run a water flow over this, and as the tubes come out, we're sort of cutting or shearing these tubes off into little teeny-weeny nanobubbles. That's very simply how the system works. The benefits of our system, because there are other nanobubble systems, is that basically, primarily, because it's a low pressure system, we have a really big reduction in OPEX and CAPEX in both, because we don't need to have big pumps and big sort of high pressure systems to deal with that. The other benefits are we have the highest concentration of bubbles that we can put in water out of any other nanobubble system. The bubbles are a really strong small size, so you get stronger attributes. We can pass solids up to 9 millimeters, which sort of eliminates all the other types of nanobubble machines that are traditionally cavitation or venturi based and can only pass sort of 2 or 3 mils max. So that's really helpful in DAFs. And again, the only issue is really we've got to make sure if you've got really strong wastewater that you have to wash your machine if it's not running 24/7 after the end with the quick water flush. Although a couple of guys from the States have removed their solenoid valves and just left the high pressure air coming out, and that's been enough to stop any build-up, but it's not typically what we recommend. So just for a couple sort of examples of case studies. So this is just from a cheese plant in the US, where they got quite a good improvement after subbing out their pressure vessel, and their final good power savings, reduction from 275 kilowatts down to 91, and a final reduction in TSS of 99.7% and just under 90% BOD. And here's another different plant. This was an ice cream plant over in the States. I'm not sure if you can see my mouse or not, but if you can see the percentage solids of DAF float sludge at 3.8% up there, that's what they were starting with. And after changing their pressure vessel out, they got just under 20% solids in their DAF float sludge. So there's a reduction in 80% of the total volume of DAF sludge that they had to get rid of, and amounted to some really strong savings at the end of the year. They also had a 35% increase in removal efficiency in terms of their outgoing wastewater. And then I've just included this slide as well to show the machine on the side when it was retrofitted in their old system. And there's just what the top of their DAF looked like, and the sludge sort of on this left-hand side It's quite a thick, sort of cakey-like consistency, and when you pick it up with a stick or touch something with it, it's sort of quite light and thick and fluffy because of that high solids percentage. So cost to the end user can vary quite a bit on what we need to install with the machine and the size that you need for your plant, but anywhere from sort of $25,000 Aussie to up to 100K. Again, we can add our system into the existing pipe work from your pressure vessel, or we can set it up in parallel on its own separate line, so you've still got the other one in backup, or you can run them both at the same time. Some guys do that too, and have found they've had the best results that way. Typically, you need maintenance as a quarterly service. Some guys do it more than that because they've found they've got better performance that way. And yeah, pretty low power consumption, anywhere from sort of 1 to 3.6 kilowatts is the most we've come across. That's pretty much it. I guess if I did have to sum it up, the key benefits for most people, typically we have DAF wastewater that you can't run through dewatering systems, and you're paying a lot to remove that. That's where the biggest benefit is. So especially with dairy producers, that seems to be where the majority of the sales are coming from. The other areas are where there's a really strong driver to reduce your outgoing wastewater, strength of your wastewater. So guys that have plant that are town-based and that sort of thing as well. They have really strong drivers to do that. It's where the best fit is, and we sort of see the best thing is if you can upgrade your whole DAF unit or plant for $500,000 or $1 million, you can put a nanobubble system for a much reduced cost and then get a lot of the benefits of that. That's the main benefits of it. And yeah, that's most of it, Karen. Thanks.
That's great. Thanks, Leon. I appreciate it. Okay, so we've got a few questions on the Mentimeter system. So just a reminder, go to menti.com and use the code 804198. So my camera as well, actually. So that code and the link is also in the chat box if you're on GoToWebinar. And if you're on YouTube on the live stream, then it's in the description below the YouTube screen. So yeah, those details are menti.com and 804198. Okay, so I will just switch over the screens to that. So okay, so you should be able to see Mentimeter screen. Okay, so the first question I have here is, would it work with oil and fatty acids without a flocculant?
Yep, it definitely works with that. Our first sort of installation we did in New Zealand was on a DAF that wasn't using any flocculants or that sort of thing, and it got a really strong improvement. It's not going to be as good as if you're using it in combination with flocculants, but typically with oil-based or your FOG levels, that's where we get the strongest improvement, and sort of the oily or fatty waters just have a much better response to nanobubble addition. Yeah, and obviously, if you're not using anything, you're going to get a much bigger jump and a really good response. So we had, I think, the outgoing wastewater almost 100 was like 90% improvement on the outgoing, what it was, but you wouldn't get that if you were using a lot of flocculants and polymers and that sort of thing prior. The response would be less.
Okay, thanks, Leon. Okay, so next question is, how do you go about sizing a nanobubble system for retrofit? I presume, is it based on water flow, TSS?
It's based on water flow. That's pretty much how they size them and the sort of recommendations we're given. I guess that's the first way. The second way is we can adjust our machines we can adjust the flow rate of gas that's coming in as well, and that has an impact too. One of the big things is that when you install a machine, it's definitely worthwhile playing around to find out what way gets the best response, I guess. We've told the guys that seem to get really, really good improvement are guys that are willing to put it in, spend a bit of time doing testing and playing around with different things, whether that's changing the polymers and flocculants that you're already using in your system, changing the flow rate of the machine to find out what works best, and even changing the cleaning product you're using in your plant to something that works well with the negative charge of the nanobubbles has a really good impact on increasing, removing more COD and that sort of thing from your wastewater. But primarily, it's matching the water flow of your recycle flow. What's been working best in your plant previously, so we'll do that.
Okay, that's great. Thanks. Yeah.
Actually, also, I should say you do need a reasonable retention time. So if you've got a really turbulent system that's a high speed or high rate DEF, it's probably not very appropriate. You probably want at least a good sort of 8, 9, 10 minutes minimum retention time, or something that's not really turbulent.
Yeah, actually, I was going to ask to follow up with that. How does the system cope with changing flow rates? Say if you've got CIP systems running on and off.
I guess most of the people have a flow rate that's when the DEF's operating, it's got sort of one flow rate. We can adjust the gas pressure. You can adjust it to a range of from sort of like, I guess 1 to 5 times the gas pressure. So you got a bit of a gas flow rate, sorry. So you got a bit of room to move within that. But obviously, if it's really slow and really long, it's because we have a separate recycle system. It doesn't usually impact too much on the nanobubble system. As long as you've got an overall retention time, that's reasonably good, is the main thing.
Okay. Great. Okay, let's move on to the next question. Can nanobubbles be used for stripping components like sulfur or ammonia from water?
I'd have to get back to you on that one. I can try and answer it, but I'm not 100% sure. Is it all right if I'll talk to our guys in the States just to make sure I answer that the right way?
Yep, sure. So if somebody wants to ask Leon that ask that question sort of directly, it's Leon.
I'll get back to you.
Yeah, it's leon.power@nanobubble-systems.com.au. But yeah, we'll endeavour to get back to you on that question. Okay. So somebody's asking here around the applications in Australia. Someone's asking if there's one we can visit and kick the tires on.
There's not any yet in Aussie, but we're really close, and we were pretty badly COVID impacted on sort of 2 that we were meant to install that we're hoping will get back going pretty soon. We've done 2 in New Zealand on abattoirs where we've put it in, and one that didn't have a scraper that was really successful, but because they didn't have a scraper on top, the sludge ended up building really thick and then didn't fall over. It was sort of a fall over system. Didn't work well with their system, but the removal and separation was really awesome. But yeah, not in Australia at present, but pretty much all the DAF ones are in Canada and America. And most of those would be in the dairy wastewater industry, but there's a couple other sort of unique ones as well outside of that. And you can also use them in fat tanks. There's been ones done in fat tanks as well.
Okay. Well, we'll maybe update everyone when maybe we're out of this COVID-19 lockdown.
We're hoping very soon we should have a first one.
Yeah. When you can escape, you're still stuck in New Zealand.
I am still stuck in New Zealand. We're waiting for the bubble to open, which should hopefully be in about 2 or 3 weeks. So we don't have to do lockdown isolation for 2 weeks before our kids inside. Would be really good.
Okay, so let's try the next one. Can the technology be scaled up to a large industrial scale economically? So they're thinking a large mineral waste ponds where drying mud or cake over a large period of time.
I guess you'd have to try and see. Don't know of any that have been done that way. A couple of guys have used it in the oil and gas industry, not for DAFs directly, but for floating off oil and getting it to the top where they could sort of remove it, not in a DAF, but similar sort of method. So I'm not sure in terms of, we haven't seen anything done by that, but it might work as long as you've got a way of removing what floats to the top. Yeah. Don't know if that helps much.
That's fine. Then just a reminder again.
You can definitely run that stuff through the machine, so you can put a lot of air in there, and hopefully that will get a good rise to the top. Okay.
Well, like we said before, you can contact Leon at leon.power@nanobubble-systems.com.au, or you can contact me at karen.clode@allutilities.com. So if there's any other questions.
We do have small machines as well. If you can do stuff in the labs that we can give you, if you want to have a play around and see if we'll work with what you're trying to do. So that's always an option.
Okay. So I think that might be the last question. It's just the other question about the stripping components and its off. I think that's it. Is there any other questions from the audience? I know I have a comment here on the chat. I just wanted to check. All right, so I have another question that came through on the GoToWebinar. So can it affect the pH of the wastewater?
No, I don't think so. Maybe a slight drop in pH, but from everything I've been told, there's never been a big change in pH.
Okay. Right. Well, thanks, Leon. I think we'll leave the Q&A session there. So let me just swap over to remind everyone again. So just as a reminder, if you would like to contact Leon to talk about more about his nanobubble systems, it's leon.power@nanobubble-systems.com.au. We're going to move on to a bit of a break now. Just give everyone 5 minutes. So just give you guys a chance to, I just have a leg stretch, have a wander around, use the facilities, that sort of thing. So we'll just have 5 minutes. So come back about 3 o'clock. So that's 3 o'clock Australian time. So on the hour for everyone else. I'm not sure where everyone is, but if you can come back then, and we'll just we'll start again with the next presentation. So the presentation is Matt from MyPass. If you are on Mentimeter, feel free to do the quiz. I put a quiz up there for just after the nanobubble Q&A. Okay, cheers everyone. Back in 5 minutes. Hello again, everyone. Just coming back. Just looking at the who's your favourite. Only 2 people have voted so far. So feel free to vote. I mean, I don't know. I think we did discuss this internally in Isle. My colleague Aldrich is on the line. He's a big fan of George Clooney. I'm not sure. I kind of maybe about Michael Keaton because he was my first Batman. I think he'll be my choice. Okay, we'll just give a few people a chance to get back to their seats and get back to the webinar, and then we'll start and move over to that. Okay, nobody else is going to vote. That's fine. That's fine. It's just a chance to do something in the break, but we can move on to the presentations. Okay, so we're going to move on to Matt from MyPaths. So I will just have a quick switch over. So just a reminder, again, we'll be using Mentimeter. If any of you haven't got it yet, it's menti.com. The code is 804198. Okay, so the next presenter is Matt from MyPaths Global. He'll be presenting a digital workforce management system. It's very interesting. Actually, he's got a COVID-19 interesting comment to make as well. So yeah, looking forward to this one. So let me just hand over to Matt.
Cool. Thank you, Karen. Right. Hopefully you can see my screen.
Yeah, that's great.
Cool. Excellent. Thank you. So, look, and thanks everyone for jumping along and attending. Look, I think it's very interesting times that we're in right now, and for me, the last few months have certainly highlighted why businesses need to have a strong digital strategy and why it's important from both a safety and efficiency perspective to ensure that we all have access to the right data and information at the right time. And I truly think that the realization many companies are coming to is that the way we operate our businesses over the next 10 years certainly has to be quite different to the way we've operated for the past 10. And so I thought before I climb in and explain a bit about some of the challenges we've been solving and partnering with industry to resolve, I thought I'd just quickly share my journey to get to this point and share a bit of context. I actually started in the utilities space and wastewater as a mechanical site engineer in construction, and came over to Australia in 2007 and ended up running a sizable maintenance services division, mobilising large numbers of trades labour to oil and gas, mining, industrial sites. And what came as a shock to me was just how terribly inefficient those labour resourcing and competency management processes were, and not just within my company, but across the whole labour supply chain. And essentially, there were huge information gaps from using old software platforms stitched together with Excel spreadsheets to manage that safety critical worker data. And I didn't even realise how exposed I was as a young general manager that in hindsight, I could not have put my hand on heart and been assured that every worker on site had up-to-date training, inductions and credentials to be doing the tasks that they were getting asked to do. And I thought I'd just show you this just for your information. I mean, you're not intended obviously to be able to read the blocks in this process flow diagram, but this is a process map just showing how convoluted workforce onboarding and allocation processes have become over the years. This is an example from the mining sector, but it's similar across a lot of sectors we operate. And it shows just how much waste is hidden across businesses with many workarounds and the proliferation of Excel spreadsheets because systems can't integrate and sort of work around a single source of data. And just in case you're wondering how convoluted this process actually is, this is a shortened version, but quite often we find more than 100 process steps need to occur from a asset owner, utility provider, requesting a worker to come to their site from one of their contractors to that individual turning up at the gate compliant. And whilst I think the adoption of technology in heavy industry has come a long way over the past 10 years, labour management remains sort of one of the most convoluted of all processes. This is just another way of showing it. This example is for a typical shutdown or project worker in Western Australia here that might work at 8 different mine sites and for 4 different asset owners and be engaged by, say, 5 different labour providers and go to several training institutions throughout the 12 months. And essentially that same information is getting stored in this example by 12 different organisations. And that means, take, for example, a working safely at heights document. That same document could end up getting stored in 36 different locations and re-verified by multiple parties. So it's just a small example, but it shows that there's a big opportunity here to improve the way we're handling safety critical data and using digitalization and technology in order to do that. And so I guess my first challenge to those on the call is to think beyond your own organisation. I believe that those of us who are trying to solve these types of problems just within our own organisational boundaries will only get part of the way there. And based on our experience over the past 7 years, solving this problem requires collaboration at an industry level, not just sort of organisation to organisation. And I'll show what I mean as we get into it. So firstly, just about MyPass to give you a bit of context. So MyPass is a single system of record centered around a digital work skills passport. And in our business model, workers are in control and can share their information with one or more employers, training institutions, industry bodies, asset owners, or operators. And essentially what we've created here is a single system of record and a common industry data set that can be used for smart decision making or predict and manage worker demands. And particularly when we plug into schedule information, the ability to kind of match that whole supply and demand equation. But in terms of our core sort of use cases, it's really about the ongoing compliance management. So that real-time assurance that every worker out there on site, whether they're your own direct staff or contractors, are trained and competent. It's also the ability to manage a supply chain, so contractor compliance and supply chain assurance to make sure that those vendors out there who may not be part of your day-to-day are turning up on site with what they need. And also the onboarding, recruitment and resourcing phase to make sure at that first contact point that there aren't any gaps. So those are the core use cases. There's a lot of others that spawn off that, which I won't go into detail here, but things like permit to work and, as I said, matching to schedule information, site access, and a range of other things. And this is just another way of showing it, which is essentially showing how a single source of truth of information can integrate up and down the supply chain. So these are 3 business partners of ours as an example. So training in our business model can come straight from the training provider into the worker's digital work passport. UGL can proactively manage that worker through their own business portal and can match that worker and those and pools of workers against their skills matrices. And then the end client or end consumer of those services, in this case Santos, can manage their supply chain of 50 or 100 vendors and again have their own compliance dashboards to be able to verify that everyone out there is compliant. And I wanted to touch on integration as well. It's all very well for us to have a system where multiple stakeholders can interact and work off common data sets and it's all verified. That's great. But that really doesn't move the needle fully and reduce a lot of that waste that we showed earlier unless you've got the ability to integrate. So we've made integration a pretty key part of our platform. And it's really important to us to allow that seamless transfer of information between e-learning, rostering, scheduling, HR systems, work order management systems, etc., so that information doesn't need to be rekeyed or rechecked. And there's certainly some clear benefits that we're getting fed back to us from industry, and this is about obviously reducing waste, wasted time, wasted resources, and wasted money, but at the same time better protecting those frontline workers. So the 3 pillars of our value proposition are around reducing the risk exposure, the cost reduction from removing all that manual keying, rechecking, and verification. But also business growth, and businesses are starting to use our platform now to actually win work, secure it, deliver it in a more efficient way, and actually access skilled and capable people in a more efficient manner than what they're able to previously. And Just one example from that reduced risk exposure too. It's not just training and quals. As was mentioned earlier, we've actually got a COVID-19 solution too, where on top of the certifications and training that a worker has, they can also upload or digitally complete, should I say, through their digital work passport, the COVID-19 self-declaration form, as well as COVID-19 awareness training. And in sectors like aged care, for example, we're storing immunisation certs and I guess key bits of information like that. So it's always on the person of the person who's moving around, but also that additional elements of competency and assurance can be tracked in real time as well. So our goal is to fundamentally change the way industries operate, and we're on track to achieve our vision, which is to empower safe, agile and connected communities. And as you can see by some of the logos on the slide, this is just a sample of 350 business partners which are on our system. Primarily our traction so far has been in the energy resources sector. And you can kind of see some of the endorsements through some of the comments there, which I won't read out. But I guess what's been really pleasing for us is we've had a lot of uptake from the vendors or the contracting companies as well, which is great. And that kind of tells us that the model that we've got in place is actually proving benefit up and down the supply chain, and not just giving the end user what they want and sort of forcing their supply chain through a clunky process. And we're also proud as well that we've had the backing of the Energy Resources Growth Centre, which is government endorsed, and also through the federal government, through the Department of Innovation program. So, I guess what we're trying to do is, as I mentioned earlier, take an industry first approach, and it's certainly gaining resonance out there with those in the industry. And so, the shift we're starting to see is definitely a shift in mindset, as I sort of alluded to at the start. This is about companies on their own, not just trying to be operationally competitive internally, but also be globally competitive and work together as an industry. We're seeing a lot of this. Again, I'll use the energy sector as an example, where they've rallied together and got a common industry safety induction because they acknowledged all the induction fatigue from workers that are going between multiple sites and having to redo inductions. There's common verification of competency standards that are coming out. So there's some great things happening, and we're sort of fortunate to be part of some of these initiatives where you need a platform that can be easily transferable and easily accessed in order to give mobility to some of these common standards and quals. So, as far as I'm concerned, to see some of these big multinational companies get together and agree on common standards is good hope and promise that others can collaborate in parallel industries too. And so, as far as I'm concerned, the opportunity is before us right now, and to really ask that question about outdated technology that doesn't talk to other systems, and question what has been in place for the last 10-20 years, and really try and embrace data sharing. And we're sort of seeing that in the form of regional clusters and other forms of industry collaboration. We're seeing data sets start to move cross industry now and be industry agnostic. And I think this is what will turbocharge the value of any one technology product or any process improvement, just beyond the immediate benefits that that piece of technology or software will give to an individual company. And so, this is where we're seeing a shift away from traditional approaches, and a shift to much broader corporate social responsibility, and the need for community engagement as well is key. And COVID is another example. We're starting to work with some of the industry bodies and regions who are trying to maximize local content, who are trying to reduce interstate travel and draw upon the local resource. But the first question arises, well, how do we know who's got the necessary skills and qualifications in our region? And if there isn't sort of an industry data set to draw upon, it can be very difficult to make those decisions. So in summary, the key takeaways that I sort of wanted to highlight here, legacy technology and processes and mindsets have certainly created significant data duplication in the past. And as I sort of put forward earlier, I think the challenge here is to think beyond your own organisation and think collaboration with your peers or other organisations in your region, just not within your industry. And there's some real wonderful opportunities there in terms of improving safety performance and productivity, and also regional engagement too. So, you know, the technology is here and now. It's not just MyPass. There's other technologies out there that are harnessing the cloud and enabling data sharing. And so I'll sort of leave you with the question, which is, you know, how can your organisation play its role in the data sharing economy and try and take that leap forward into what the next 10 years is going to look like. So I'm sure all the contact details will be distributed afterwards, but yeah, that's sort of the content I wanted to cover now, and my contact details are just on this last slide there if anyone wants to reach out.
Thanks, Matt. Yeah, everyone's welcome to obviously reach out to Matt on his email or phone number. Please feel free to do that if you're interested in hearing more about. I think it's very interesting, sort of that one sort of central source of truth. I think is very interesting. Getting to that point, we have some questions already, but if you do want to ask a question, please go to menti.com, menti.com, and use the code AT4198. Like I said, it's in the chat on the GoToWeb, also in the description underneath the YouTube live stream. If you go through there, you might have to go through a few pages now to get to the MyPass Q&A. You don't have to add anything on all the pages. You can just click through to get to the MyPass Q&A. Don't feel you need to add a comment on every single page. So I'll kick off. I'll transfer over, if you don't mind, Matt, and just go to my screen with the questions. Okie doke. Okay, so we've got a long one here. How would you suggest an industry go about embedding this, say, within the dairy manufacturing industry? What are the steps required to get it off the ground, and who needs to be in the room?
Okay, that's a good question. So, look, it doesn't really matter what industry. There's no sort of different approach we're sort of taking, as long as the industry's got a degree of regulation and it matters whether people are trained and competent, then that's sort of the prerequisite. But in terms of getting going, this is where cloud-based technology is really beneficial. Like, you're literally talking months, or in some cases weeks, rather than, you know, sort of big prolonged periods to get something deployed. And so the steps that we take depends on whether we get engaged by the contracting company or whether we get engaged by the asset owner or an industrial partner. But if we assume it's from an industrial business partner, we essentially engage with the health and safety team as well as the operational leaders who are responsible for the safe delivery of work on their sites, understand all the criteria and what they're looking for, and inevitably it seems to come down to the same thing, which is real-time tracking and assurance of who's on their sites. But once we've validated that, then they send a note out to their supply chain to get set up. And we do all the onboarding of the supply chain. We help them get all the workers uploaded into their portal so they can do bulk invites of workers. We help them set up the digital work passports for their individuals. All the individual workers get direct login access to their work passport. The vendors get access to their portal, and all that information aggregates up to the sort of end user or the asset owner. So, you know, really it's a pretty quick process. We have done it in weeks before with sort of hundreds of workers, particularly for turnarounds and that sort of thing. Could
this be done? Sorry, Matt. Could this be done as a collaborative thing? So if all the dairy industry partners came together, like the manufacturing industry, they came together and they wanted to do it as a group.
Absolutely. Yeah, absolutely. I think where that gets the most power, so there's two ways of looking at it. There's creating standardization at an industry level. So let's just say the dairy industry did what the oil and gas sector has done, which is said, let's try and create some common role-based competencies, so it's not confusing for a worker a specialist might go from one dairy manufacturer to another, and it's, you know, a different standard in terms of a working height certificate. They want 3 years validity instead of 2, or whatever it may be. Or sorry, 2 instead of 3. So I think there's an opportunity to standardize around role-based competencies. There's the opportunity to potentially standardize around health and safety induction, so everyone's not repeating multiple inductions and spending time and resource for that. So I think the big opportunity for rallying as industry is standardization. We're seeing the same thing in healthcare, where the industry is trying to standardize around the aged care sector, around what those common base criteria they are. that they expect from an individual. And then where it can equally be as powerful, the other approach is looking for areas where there's already a critical mass of users of a system like ours. So, for example, in Taranaki is obviously, in New Zealand's a big, obviously dairy region as well as oil and gas, but the same contractors move between both. And so we've already got 100 local contractors in the Taranaki region due to contracts we have with Methanex and with Beach Energy. But those same contractors go to Fonterra and go to other industrial sites, Balance being another one. So that ability to kind of tag on, if you like, to regions that are getting momentum can be another way of getting off the ground quicker.
Yeah, I understand. No, that would be a good collaborative way to approach it. Okay, the next question here is what other types of data can you store about workers apart from their training and certificates?
Yeah, so what we have at the moment, we have sort of the core unique identifiers of that individual, or identifying information. So we have physical addresses, obviously we have email address, we have their gender, we have ethnicity, we have emergency contacts, we have employment history, we have worker schedules as well. So if there's sort of a scheduling activity that needs to happen, we can detect whether workers are already pre-booked or available. But in terms of the training and certs component, as I was mentioning before, there's no limit to what you can build on top of that. So we're already plugged into e-learning, so any inductions and training, so any online learning and training can be added. So we're starting to move into the CPD space as well, in the health sector, where they're trying to track units of attainment. But basically anything that has an evidence or an output associated with it, be it a digital certificate or whatever it may be, we can store and keep as part of that portfolio of that individual.
Yeah, and just a sort of, I guess, a question linked to that I was thinking of is around the security and the privacy element. How do you manage that?
Yeah, good question. Sorry, I didn't really mention that, but believe it or not, there's only just under 200 companies across Australia that are ISO 27001 certified, which is the ISO standard for information security. We made a decision as a business to go down that process in 2018 just to make sure that we sort of had our license to operate in place, and so we take that very seriously. So it's a whole range of features. It's the way we store the data on secure AWS servers and Amazon's ISO certified as well. It's the way we restrict access to only those individuals who need it, and workers are always in control. So the worker by default doesn't become visible to other organizations unless they accept an invitation request because they're already known to that company. And then we do all sorts of things from a technology point of view. So, we're doing our annual penetration testing, which we get a third party to try and penetrate our system over about a 2-week period, and quarterly reviews and all that type of stuff. So there's a whole sort of bundle that wraps around it. But yeah, it's something we certainly take pretty seriously in our architecture and the way we sort of allow people to have access.
Okay, that's great to hear. Thanks, Matt. Okay, we'll go on to the next question. So is this used for both internal workers and contractors? Is it the same system?
Yes. Yep. So it just means they're sitting in a different worker pool on your dashboard. So you can configure as many worker pools as you like. So you can have your internal worker pool and a slightly different matrix for them in terms of what they require, and a different matrix for your contractors. Okay,
that's good. And the last question, would this also manage lone worker safety or journey management?
Not at this stage, but funnily enough, I was just talking 2 days ago to an award-winning system that sort of also got a grant beside us recently, which is called Jesse. So I don't mind doing a plug for them, JESI. And we're talking to them about potentially collaborating, because they're sort of a leader in that space, to making sure people can check in on journeys and so forth. And if we can kind of manage a bit of a data transfer in some instances where they can track how long someone's been on a journey and moving between sites, and we know when that worker clocks in and clocks out, there's a big benefit from a fatigue point of view there too. So the answer is no for us, but we would integrate with a system like that we think does that pretty well.
Okay, no, that's interesting. Thanks for the tip and the technology to look at. Okay, that's I know we have one more question, I think. So what's the business model? Who bears the cost? I think that's the last question today on this.
Yeah, so we run off a pretty modest flat fee for the asset owner or the industrial facility. So they get that kind of cost assurance, and that gives them the ability to have all the rolled up dashboards and to be able to request resources through our platform and so forth. So that's sort of an annual 12-month recurring license fee, which they can opt out of at any stage. And then we engage with the contractors if it's used externally. We engage with the contractors direct. If they're not already subscribers of our platform, then they pay a variable subscription based on how big their worker pool is. So small companies, will only pay $1,000, $3,000. Bigger companies obviously pay more than that, but it's very accessible the way we've set it up, and that means that those contractors can use that same subscription across multiple sites without having to sort of re-sign up. And so that's where we're getting a lot of momentum and a network effect that's kicking in, where service companies or contractors are getting enough benefit out of it. They're actually promoting us to their clients and saying, well, why don't you just plug into our data set rather than getting us to key into all these standalone portals we've got? And then that company picks us up, and then they invite their supply chain. So it's a nice kind of reinforcing business model that's been established because we've focused so much on trying to give benefit to both sort of layers. And it's free for workers too. Sorry, I didn't mention that. Free for workers. Any worker can sign up on our platform. Anything they upload, we'll verify at no charge to them. We just want to make it easy to engage.
Okay, yeah, no, that's I think that's an important point. Okay, well, thanks, Matt. I appreciate you going through your presentation and answering the questions from everyone. If you have any more questions, if anyone's interested in hearing more about the MyPass system, about what they're doing with the healthcare side or the COVID-19 certification, I think it's a very interesting aspect of the system. Please email Matt, msmith@mypassglobal.com. I'm sure we'll be happy to answer any more questions that you have, or just contact through to Isle. So Karen.Clode@isleutilities.com. We can put you in contact with Matt or answer any questions that you have about his presentation or the other presentations so far. Okay, so we'll move on to the last presentation. So last but certainly not least, not at the bottom of the barrel, we're very pleased to have David Knight from Electrotherm presenting their fuel-free, emission-free power from waste heat system. So I will transfer over to David.
Thank you. Thank you, Karen. You see my presentation?
Yep, you can see it fine. Go ahead when you're ready.
All right, thank you. Thank you, and welcome to everybody to Electrotherm and the Power Plus generator. As Karen said, we're a waste heat to power generator. So Electrotherm, we were founded in 2005, and since 2016 have been part of the Bitzer Group. We have a leading engineering team of organic Rankine cycle design and application engineers. We've successfully developed the Power Plus generator with more than 80 units installed worldwide, with a combined fleet time of 1.5 million hours. Our first commercial unit was installed in 2011, and that unit is still in operation. Our factory and our manufacturing is at Flowery Branch in the USA. So what is an ORC? An ORC is not a mythical character from Middle Earth, but a low temperature ORC is a heat generator that is designed to generate electricity from heat temperatures up to 150 degrees centigrade. And the Power Plus generator is specifically designed to use those low temperature heat resources to generate a high value electricity, and we can use a wide variety of heat sources. So how does it work? We're very similar to a steam cycle, but with a low temperature organic fluid that evaporates at a much lower temperature. So we have a heat source, and this gives us hot water, which passes in through our evaporator, through our preheater, and then is returned to the heat source, normally in a closed circuit, or it can be used for other resources, such as district heating. We need a condensing system, so cold water in, heat out, remove the heat from the working fluid. So our working fluid goes from a low pressure liquid to a high pressure liquid to a high pressure vapor, a low pressure vapor, and the pressure gradient between the high pressure and the low pressure enables us to produce the electricity. So basically, the higher the hot water temperature in, And the lower the cold water temperature, the higher the gradient, the more electricity. So our family, we have a basic unit, which is the 4400B, which has a power output to 75 kilowatts. And we have a larger unit, the 6500B, which has power output up to 125 kilowatts. Currently, we have several new products under development. We have the PowerPlus B250, which is due to be released early next year. This unit will provide improved performance, a greater power output up to a 250 kilowatt gross. We'll have a larger capacity expander and an increased heat exchanger capacity. Second product line, which is quite exciting, is the new active cooler. The new active cooler is a self-powering engine cooler, which is designed to replace traditional power-consuming radiators. It uses the waste heat from the jacket water system to generate power via an internal ORC. So it uses the inlet and return temperatures to the engine specification. Scalable, it will reduce engine derate at high ambient temperatures. We do multiple cooling circuits, the jacket water, low temperature water cooling, the standard interface. Our first unit is due to be replaced later this year with a larger unit early next year. So our equipment layout. So I'm just using the 4400B as the example. This is the front view. It shows our control panel and the green monster expander. Side view, which shows you where the feed pump is. And the rear view, which indicates top left is our condensers. The bottom left is our preheater. In the center, their evaporator. So it's a well-engineered, compact system. And currently, our engineers are working to make it even more compact and bring it up to date. So our power plant, which we use, is the Bitzer HSE85 expander, which is a derivative of the Bitzer successful family of compressors. So basically, we have high pressure in at one side, low pressure at the other side, passing across the expander, turning the generator. So the advantage of the semi-hermetic solution is we got an integrated induction generator. We don't have any shaft seals, and we have a much less complex oil circuit. Electrotherm uses the hot water as our carrier. So why do we use hot water? Water is an excellent carrier of heat with known properties for heat transfer. It is safe and non-toxic. It is not an invisible killer. It will not damage the environment, and it's easily transported through pipes, means that we can place our equipment to suit a facility layout. Our working fluid is R245FA, which has a proven performance as an ORC working fluid, boiling at 15.5 degrees centigrade. It's approved under the Montreal Protocol. It's non-fallible, environmentally safe, non-ozone depleting. It's in the moderate range of GWP. However, we are aware that there's action now on GWP, and we are at the forefront of testing the next generation of working fluids. And what we're looking for is an ultra low GWP, basically less than 1, and performance similar to what we get with the 245FA and availability. So what are our advantages and our benefits? Commercially proven and reliable technology. As we said, we have 80 units operating, 1.5 million hours combined runtime. We generate renewable energy from a small footprint with low visual impact. No tall towers, no reflection from the sun. Has versatile application, combined heat power capability. It's got robust modular design with ease of installation, operation and maintenance. Our twin screw expander operates at low speed and variable heat input. So as your heat goes down, we still operate safely. Supported worldwide by Bitzer International through their service network Greenpoint, and it's an economic solution for converting a waste resource into high value electricity. So a client comes to us with a potential project. So we do an evaluation, and our first evaluation is we look at how we're going to cool, whether it's a radiator or whether there's alternative water. We then select the type of expander, type of machine, and whether it's a 50 hertz or a 60 hertz application. We enter the heat input, and this stage it's 150 degrees centigrade, 11.9 liters per second. We look at the cooling water. If we're using a radiator, we enter the ambient temperature. If it's an alternate cold water service, we put in the actual temperature of the cold water. And by pressing the click here to calculate button, we get our results. In this instance, it's 125 gross power with 104.7 net. We also do an economic assessment, and that uses 4 factors. We look at the value of electricity, the overall capital cost, the runtime of the plant, and the output from the Power Plus generator. And that will calculate us a return on investment and also a simple payback. So our applications, as I said, they're many and varied. And primary applications, stationary engines. So we take the waste heat to power from jacket water systems and also from the exhaust systems. Now, it doesn't matter if you're using current fuel such as diesel, LNG, or a biogas, or you're looking at the next generation fuels, which is hydrogen. There will be heat, and you'll need to improve your efficiency, and we can do that with the Power Plus generator. And that's particularly important with hydrogen because hydrogen will be more expensive. You need more bang for your buck. Biomass and biogas. So basically, in biomass and biogas, you burn the biomass and biogas into a high efficiency boiler. The hot water comes from the boiler into the Power Plus generator, and we generate electricity. So the sources for that are wastewater treatment plants, where you have an AD plant operating, timber industry, where you have waste processing from your processing, forestry waste, or any other organic waste which you can burn in a boiler. The advantages are for a wastewater treatment plant, if you have low level of biogas or it fluctuates, then we can safely operate and still generate your electricity whilst removing emissions. Nature's power, we can use micro geothermal. And this picture is of a application in Japan where we're taking geothermal water and generating electricity and also cooling the geothermal water for another use. Or we can use solar thermal, where again, you take the hot water through the Power Plus generator. Or if they also use a heat sink for load shifting, we can then use the power from the load shifting to generate electricity. Waste to energy and incineration. We looked at several projects and currently have several projects being investigated where we take the waste heat from the secondary chamber, which is typically very high temperature. We convert that to hot water in a heat exchanger. We generate power, and we can do that without disrupting your emission control systems. Flare to power is becoming something very important around the world. The UN are taking action to reduce flaring. They're looking to lower emissions, and they're looking for a better use of infinite resources. So the applications here is we take the flare gas, we burn that within a controlled environment in a modern boiler, hot water into the Power Plus generator to electricity. So with the controlled environment of the burning, you reduce emissions significantly. And we've proven this system on an oil field in North America. So the sources of flaring can be oil and gas fields, refineries, wastewater treatment plants where you have biogas in your flaring, or a landfill where you also have gas which you are flaring. They have industrial waste heat to help with energy efficiency. Basically, have heat, we've got a solution. We can generate baseload renewable electricity, so it's reducing your operating costs. So this just gives you an example of the type of projects that we've been looking at. I'm doing process cooling in a particular plant with a power station. They need to reduce the temperature of a condensate return from a dairy factory. So we're proposing a 3-stage cooling using the Power Plus generator. As I said, we have a wastewater treatment plant about to come online in the United States where we use flare gas. So we're reducing the emissions and generating power. We have several geothermal projects and flare to power projects under consideration currently. So what do we offer? We give you a commitment to work with all our clients in the development of solutions for your heat to power generation. We have an opportunity to generate baseload renewable energy using either primary or waste energy heat sources. We will do an assessment, a detailed submission on your quotations for a supply of our equipment, and we will also assist you to look at a full turnkey offer if required. we provide a technology advanced solution. It's not a black box, it's a well-developed system which we know that is proven and works, and it all comes in a standardized design. We give you access to our international team with experience in the supply, design, and installation of ORC-based power generation systems. And that's not just internally with Electrotherm, where, as I said before, we have a very passionate team of people, but also with our system integrators who have experience in field installations and operations. We have worldwide support being provided by the Bitzer Group. This is just a picture of a recent installation in Rothenburg, Germany. It's a wonderful name. And this one you show, we've loaded these onto a frame for ease of installation, and the cooler is actually placed on top of the container. And this gives you an indication of the standard of workmanship that comes with our equipment. So as I said, in Australia, we work through Bitzer Australia, and this is a list of contacts at Bitzer Australia and also for New Zealand. So we are here, we have a solution, and we will work with you to bring any project that you may have to successful conclusion. And our contacts are below. Thank you for your time.
That's great. Thanks, David. I appreciate the presentation and going through that with us. We have a few questions already, so if anyone is interested in asking David more questions, please go to menti.com and use the code 804198, as I mentioned before. Those details are in the chat on GoToWebinar, or they're in the information box below the YouTube live stream. So yeah, menti.com and 804198. You might have to scroll through a few screens to get to it, and because we're at the end. Okay, so I'm just going to take back the presentation from you, David, and just put up the questions. Okay, so I know you, David, I know you touched on this already, but could you just summarize typical heat sources from your previous installations?
Anywhere where there is heat, we can take heat from an engine where we do the exhaust gas or the jacket water, industrial sources, as long as we can transfer that heat into hot water. So we can pass it through a heat exchanger, we can collect it through a heat collector, we can generate electricity.
Okay. Is there any sort of quality that heat or the water needs to be? I mean, is there any sort of requirement on particulates? We
need about 500 kilowatts thermal energy available to do the basic operation. And we have high quality water requirements because of the type of heat exchangers we have on our machine. But that's easily handled by having an intermediate heat exchanger. So we might have dirty water heat exchanger and our clean water cycle.
Right. Okay. So the next question, what types of waste heat media, so water, gas, can be used? Can the system be plugged in prior to existing cooling towers?
If there's enough heat and there's enough thermal energy available, yes, we can.
Okay. And what was that thermal energy again? You said it was a minimum.
The minimum is around about 500 kilowatts thermal. Okay. It depends on where we are. If we're in a particularly Arctic situation where we've got very cold air, very cold water, it can be less. But typically for Australia, we need about 500.
Okay, that's great. Okay, how long does it take to get one set up and running?
The manufacturing cycle is 24 to 26 weeks. Then you've got shipping, and then about four weeks and we're up and running. So it doesn't take a huge amount of time.
Do you manufacture those in Australia?
No, they're manufactured in the United States.
Right. Okay. Okay, thanks for that. We'll go on to the next question. That's that one. Oh. What is the lowest waste heat temperature that is economically viable?
Around about 80 degrees centigrade. If we can get that's the lowest temperature, hot water temperature that we will take into our machine. And it then depends on where we are taking the heat from. So generally for a flue gas, you're talking about 100 degrees centigrade is your lowest level you can bring your temperature down to. But
Okay.
for hot water, we'll take 80 degrees. So the
Okay.
higher the temperature, the more power.
Yes. Okie doke. That's great. What is the typical cost of energy per kilowatt hour?
We can get down to around levelized cost of energy around about 4 cents kilowatt and below.
Okay. So the next question is, AC plants worldwide is great, but not evidence of massive industrial acceptance. There seems to be a disconnect between environmental rhetoric and actual commercial implementation. Is that correct?
It runs down to economics. And economics are that a bigger system and a higher temperature system, and there are higher temperature ORCs around, will produce more power than a low temperature. So we're probably the last level where they will implement to get better in efficiency. Now, if you have high fuel costs, such as in the Pacific, where their diesel costs are high to run their diesel generators, then we become applicable. But if your feed-in tariffs are low or your fuel costs are low, there's not the push to implement these systems. Now, as we said, with the flare gas, this is now coming under UN investigation. They wish to get rid of flaring because of the huge amount of emissions that get transmitted into the environment. So there's now impetus to look at flaring. And 2 weeks ago, I looked at a project with 30 machines based on flaring in an African country. So the perceptions are changing.
Yeah, I hope so. Thanks, David. Okay, moving to the next question. What's the typical advantage of screw expanders over turbines?
We operate at slower speed. The twin screw expander runs at 3,500 rev per minute. A turbine runs much higher. And the other huge advantage is if your heat load changes, so it reduces, and you don't fully evaporate your working fluid, we safely operate. It will not damage the twin screw turbine. Basically, what happens is our power output will go down because there's not as much pressure passing through the turbine, through the twin screws. And then as the heat comes back, we just ramp back up and go. So from a safety point of view, if you've got variable heat load, the twin screw expander is an advantage.
Okay, thanks for that. Yeah, it makes sense. Okay, this is the last question. So if you want to ask any more questions, feel free to. What's the water volume per kilowatt per megawatt hours?
That depends so generally our larger machine will run up to 23 litres per second. The smaller machine runs to 15 litres per second. And our future machine will go up to 32 litres per second. It's all about the output is determined by temperature in cold water. If we get that up right, and then the amount of flow will just depends on that temperature change. It's basically that.
Right. Okay. So more temperature dependent than flow dependent.
Yes, it will. So if I'm coming in at 150 and I've got a very low temperature on my colding side, I may only be running at 7 litres per second to get the full output.
Yeah.
But if my cold water is sitting at 35, 40 degrees, I'm running at something like 20 litres per second to get the same output.
I see. Okay. That's interesting. Thanks. Okay, I have another question here. What's the typical maintenance of the unit?
We have a full plan maintenance system up, running, and proving, and it's basically a fitter. So it works every 4,400 hours. We have a cycle. The initial one is basically checking for leaks and everything is running correctly and cleaning the machine. And every 4 years, we look doing a major maintenance on the twin screw expander. So there's a full plan, and it's a fitter. It is nobody special. And we also have, for clients who like it, an offline monitoring system, so we can monitor remotely, and we can actually tell you the performance figures of the machine and what needs to be adjusted to get the performance up to optimum.
Okay, that's interesting. I think that's all the questions that we've got unless anyone else wants to add in the last question on the system. I think I had, I think that was, yeah, I think that was it actually. Doesn't look like we're going to get any more questions in. If you do have any more questions for David, you can contact him directly. So his email address is dknight, so dknight@electrotherm.com. So feel free to email him directly to ask any questions. If you want to contact us, that's fine. Feel free to contact us regarding any of the technologies that are presented today, or about the work that ISLE does and the innovation partnership model. I just want to wrap up and say thanks to all the presenters. I appreciate everyone's time and effort in coming along and presenting their technologies and answering the questions. Thank you to all the attendees, everyone on GoToMeeting, and everyone who's managed to join us on the YouTube live stream. I appreciate your time and attention and asking all the interesting questions. Feel free to continue to add any comments or questions or points on that. We'll make sure they all get to the technology companies so they know the information, so they have that information, the feedback. It's appreciated by everyone. These are the details of all the presenters. Feel free to contact them directly. Oh, I have one final question here on the system. Thanks everyone. So just a final thank you from myself. If you'd like to contact me to ask me any questions about any of the presenters or about ISLE and the Innovation Partnership and what's the work we do, I'd be very happy to talk about it in more detail. My email address is karen.clode@rutilities.com, so feel free to reach out. Everyone will go to webinar. This has been recorded, so you will get a link to the GoToWebinar recording. I'll also send around a feedback form. I appreciate it if everyone could fill that in. It's only going to take you about 2 minutes. It just gives a bit of, helps us inform how we run these webinars in the future. Hopefully, maybe in the future we'll all be together, but in the meantime, we hope to provide you guys with informative webinars well, maybe we'll see you again then. But yeah, thank you. Thank you, everyone. And we'll see you again soon, hopefully. Bye.